Hello everyone. Pag-usapan po natin ngayon yung paggamit ng Raspberry Pi for machine learning. So ang kailangan nating hardware is Raspberry Pi 4 Model B, either 4GB or 8GB memory. So mine, I use the 4GB memory. We also need a USB power adapter, minimum of 3 ampere current rating, and a heatsink para sa mga integrated circuit sa loob ng Raspberry Pi board. We also need a micro SD card, 16GB or 32GB. In my case, in my setup, I use the 32GB micro SD card, so such that I have enough room to store my Python scripts and other software needed. We also need a micro HDMI to HDMI cable. The micro HDMI cable is only needed during a pre-setup, although there are information on the net that you could set up your Raspberry Pi without using any monitor. But for my case, as an initial, I used an external display monitor because I want to view what's going on. So we also need a casing with fan in order to keep our Raspberry Pi cool. We also need a webcam or a Pi camera, so that we could be able to capture images from our video needed for our machine learning Python script. But in my setup, I used my Android phone as a webcam because Android phone has a better camera resolution, and you could be able to adjust the lighting. And to set up your Android phone as a webcam, we need to install an IP webcam, an Android app. And with this IP webcam, we could be able to connect our Raspberry Pi to this IP webcam. But I will not discuss more about the IP webcam. It's out of scope for this discussion. Okay, now on our Raspberry Pi OS, I decided to use the Ubuntu 20.04 LTS, long-time support for Raspberry Pi 4, although we could use the Raspbian OS. And once we've downloaded Ubuntu 2.04, we need to write the image of Ubuntu 2.04 to our micro SD card. So we use the Balena etcher to write our Ubuntu image to our micro SD card. So next is our Raspi OS setup is in preparation for our boot up. We need to connect our Raspi micro HDMI to our external monitor, connect a keyboard through our Raspberry Pi USB. We also connect our mouse to Raspi USB, although mouse is optional here, is not needed because our Ubuntu 2.04 OS is a headless operating system. When we say headless operating system, it means that it does not have any graphical user interface on it. So you'll be doing everything using a command line interface. So we also need to connect our Raspberry Pi through our local area networking at home. There's a way to set up our Raspberry Pi via Wi-Fi, but I will not discuss that matter here. We could use the LAN cable. So next is we're going to insert our micro SD card with the Ubuntu OS for Raspberry Pi at the back of our Raspberry Pi board. There's a slot there for our micro SD. Then we plug our USB power adapter to power up our Raspberry Pi. Then once the Raspberry Pi is powered on, there's a login prompt. So we need to log in as a user Ubuntu, and the initial password is Ubuntu. Then it will ask you to change the password, so depending on what password you like. Then once we've completed the login sequence, we see the terminal prompt or the console prompt. The first thing we're going to do is we're going to update our Ubuntu OS. So to update that, there is a command to initiate an update process. Then once the update process is, we need to reboot our Ubuntu in order to get the updated Ubuntu OS to boot up. And after that, we're going to set up the Wi-Fi, but I'm not going to show how we're going to set up the Wi-Fi. Okay, I have a note here that Ubuntu Raspi OS is a headless OS, which I mentioned earlier, that it is an OS that does not have any GUI. So on our succeeding usage of this, our Raspberry Pi, is we're not going to use any external monitor, but rather we're going to use an SSH approach to remotely control or do our thing on our Raspberry Pi. So of course we also need another computer, like our desktop computer at home or our laptop at home, to connect to our Raspberry Pi via SSH. Do take note also that the IP addresses of both your laptop or desktop PC and the Raspberry Pi must belong to the same subnet. Okay, for the machine learning hardware, we need a laser transmitter and a laser receiver. There are other approaches to do our hardware for image capturing via our webcam. Is we could use the optical interrupter module, but in my case I use the laser transmitter and a laser receiver. Okay, for the machine learning software setup, we need to install Python 3. We need also to install PIP 3. PIP is the installer for Python 3 module and packages. So we need the OpenCV. OpenCV is an open source computer vision. So we're going to use this OpenCV to capture images from our webcam. In my case, I use my Android phone as a webcam. Then we need to install TensorFlow. TensorFlow, by the way, is from Google, and it's supporting dependencies and libraries. Then we need also to install the rpi.gpio Python module for Raspberry Pi. So the rpi.gpio is a library for Python that we could be able to use our GPIO ports on our Raspberry Pi board. Okay, that's it. Next, I'm going to show you an actual video I've recorded previously that has an actual demo. Okay, so this is my laptop, by the way. It's an old one. It's about 15 years old. As you can see, I've run the Python script that I created that do machine learning. So as you can see, the status there is that TF model loaded successfully. So TF stands for TensorFlow. Then the laser detector sensor is also ready. The press Ctrl plus C is just a way to end this program because I put it on an infinite loop. So by the way, the TF model that we loaded is I trained this model not using a Raspberry Pi. I used my desktop PC at home, powered by Fedora 32 Linux 64-bit. So I have a bunch of pictures there that differentiate defects of physical chips, particularly the dual inline package. Just a demonstration purposes, so I captured the different images at different angles, and the criteria, the different defects there is just inward inward bent pin. I have also an outward bent pin, a missing pin, and the last one is no physical chip damage. This is just for purpose of demonstrating on how machine learning image classification works with Raspberry Pi using TensorFlow. Okay, let's move forward. So everything is loaded. So as you can see here, this is my setup. The one on the left is our laser transmitter. The one on the right is our laser receiver. So every time our laser is cut off, it triggers an event callback to our Python script that it will initiate uh, an image grab from our video capture, which is by the way our Android phone. My Android phone as a webcam, and the one on the center farther away from us is actually my Raspberry Pi on a casing. Let's see, keep this to show something. So this is an example of a chip, a dual inline package chip that I'm getting an image capture. I'm going to get an image capture from there using my Android phone. And the Raspberry Pi and the Android phone are connected via Wi-Fi, so that I could be able to grab the image from a video frame. So I'm positioning my digital camera recorder because I'm going to try to initiate blocking the LC. When I block the laser, it starts the prediction process with TensorFlow. So currently it detects that there is no physical defects found with a 72.1% confidence level. So I'll move forward the video. This is just so I make another image prediction, the same chip. So you see the percentage of confidence is not really that accurate because it will depend on how you position your device, test subject, and how you position your camera, and the most important thing is the lighting. There should be no shadow in it, but I don't have a way, I don't have a studio room that could be able to control the lighting. So I've demonstrated different. So this one right now is a missing pin and some bent chips, bent pins. So let's see. So now it detected a missing pin, so I put a dual inline package chip there with a missing pin. Then next I put back the chip with no physical damage. So as you can see, it's not really that accurate because this is just a demonstration purposes. The many images that you're going to put in your training model, the better. And the most important thing is that when you capture your images for the training model, it should meet the criteria that lighting is there, proper lighting is there, angle of the camera, all position, all angles. So let's proceed. I'll fast track the video. So next I put a chip with an outward beam pen. So it detected 61.74% confidence, but actually in actual, the chip that I put has a bent pin. So I put back again a chip with no defects, just to show you that image classification, machine learning in Raspberry Pi is doable. Of course, my Raspberry Pi doesn't require any GUI. It's really a headless. I have a reason why I use headless operating system in order to maintain the temperature of the Raspberry Pi cool. Because if I'm going to put GUI interface there, it will add more processing to a Raspberry Pi, which will induce heat. So I show you again the setup I have. It's actually a crude approach to. So every time I block the laser, it starts to do an image capture from our video and then do the prediction with TensorFlow. This still can be improved by putting a lot of images, different lighting, and retrain our model. So again, there is an inward bent pin found with 74.56% confidence. So this is a demonstration. So a closer look of our laser detector, a closer look of our laser receiver. Oh, by the way, the laser detector, we could use laser pointer, and it can also be detected by our laser receiver. So see, that's a close-up view of our chip. This is a close-up view of my Android phone on a tripod. So once you've set up your IP webcam on your Android phone, it run a server wherein we could be able to access the server of our Android phone. It actually shows what our Android camera is seeing, and I use this web server approach to capture the image instead of connecting a webcam to our Raspberry Pi USB port. So that's it guys. I hope this demonstration shows our capability that we could use machine learning image classification for detecting chip defects, and this can be expanded further to use for visual inspection on our any devices. Thank you. Good day.